The objective of this project is to develop a new component from the whole process, since CAD drawing, EdgeCam, machining, and process plan. The program we use to make our CAD drawing is Fusion, and the drawing makes allusion to the Temple of Heaven in Beijing. After analyzing the structure, we saw we could make all the features the product needed to have. In the drawing, we can see that we don't have any groups shorter than 5 millimeters. That's because we don't want any collisions with the CNC machine. Now I'm going to explain the process plan. The book we used was called Machining Data and Handbook. We chose this table because it was the most useful and the one that was the nearest to our material. From this book, we could get the depth of cut and the fit rate. When we got these two components, we could calculate the velocities and RPMs. When we arrived to CIMA, the professors told us to change some velocities due to the experience they had. But one velocity we calculated from the formulas we had learned in class was the 53. Our EdgeCam program has 14 operations. I'm gonna show them and explain them.
First, we did a facing.
Then we did a roughing from the right, and then a roughing from the left.
Then we did a finishing from the right. Then we did a second finishing from the right. Then we did a grooving roughing and we did its finishing grooving. Then we did a second grooving roughing with its finish. Then we did a finishing from the left. Then a third grooving roughing with its grooving finishing. Then we did a finishing from the right. And lastly, we did a parting off. Now we are gonna show you the simulation of our EdgeCam program with its steps.
Now I'm gonna explain the process plan. First, we have a facing, then we have a roughing right one, then we have a roughing left, now we have a finishing right and a finishing right again, then we have grooving roughing one, then we have another grooving finishing one, now we have grooving roughing two, and we have grooving finishing 2. Then we have finishing from the left, grooving roughing 3, grooving finishing 3, finishing left, and then finally parting off.
To locate the zero, first we need to start the spindle. To define the RPMs, press M3 S 1500 end of line. Press, insert, and run. Then we move to the face of the workpiece manually. When we are doing this, we can observe the movement in the display and in the machine. To calibrate the zero, the tool needs to touch the piece. Once it touches it, we remove the tool and calibrate the zero. To tilt the machine, we press offset word, then go to the coordinate system G54. Go to the edge we want to calibrate and press set 0.0 and measure. We could see the value changes. Then we go to absolute coordinates and now we could see the zero. Once we define our zero, we can start. We go to Edit Program, then go to our NC code, lower the feed rate, click Memory, and start machining. We can also see the process in the display.
this project, we learned how to apply our knowledge from past courses, and also we had many learnings from this project. One of them was how to change the drawing and how it can affect the finished product, since we had a very bad drawing and the dimensions were incorrectly applied. We didn't have a good presentation with the piece, and this affected us since we had to make again the drawing. Another problem we had was when machining the piece, we needed to change the stick out part to 110 to 115. This changed the vibration, and the main conclusion was on length and vibration is proportional. When we increase the length, the vibration also increases. Another learning we had from this project was to organize our time. Since this project was a try and failure, we needed to learn that the project wasn't going to be linear, because when we made a step forward, we had to make two backwards to make sure the final product was with good conditions. Also, we learned how to organize our time because we had to go to CIMA because we don't have HCAM in our computer. And this made us a very hard work because we had to go on the weekends and spend a lot of time in the project, but it was worth it because now we can have all the knowledge we need to have to go to CIMA and turn a piece with a CNC machine.